वेलकम स्टूडेंट्स। आज के इस एक्सप्लेनर में हम फोर्स और न्यूटन्स लॉज ऑफ मोशन के जो सबसे इंपॉर्टेंट कॉन्सेप्ट्स हैं ना, उनको मास्टर करेंगे। बिल्कुल जीरो से स्टार्ट करके एग्जाम रेडी लेवल तक जाएंगे। और हाँ, फोकस रहेगा पहले दो लॉज पर। तो चलिए शुरू करते हैं।
So, let's start with a really simple question. Think about this. Pushing a door, dhakka dena, or pulling a rope, rassi ko khichna. And what about that amazing cover drive by Virat Kohli, hitting a ball? Now, what do all these actions have in common? Have you ever thought about it? Well, they're all examples of the exact same thing. Force.
All right, so that brings us to our very first topic. What exactly is force? Now, this isn't some super complicated concept, okay? It's actually something we use in our everyday lives all the time. So let's just break it down.
Okay, in very simple terms, force is just an external effort. A push from the outside. It could be a push, it could be a pull, or hey, it can even be a twist or a stretch. So what does it do? What's its job? Well, its main job is to change, or at least try to change, the state of any body or object. That's it.
So, what does force actually do? What are its effects? Well, let's look at the 5 main things it can pull off. First, it can get a football just sitting there at rest to move. Second, it can stop a moving car when you hit the brakes. Third, it can change the speed. Pedal your cycle faster and you speed up. Fourth, a batsman can hit a ball and completely change its direction, right? And finally, number 5, you can stretch a spring and change its shape and size. So you see, there's one common thing in all of this. Force is all about bringing change.
Okay, but that begs a question, right? What happens if there's no force? What then? Well, the answer to that comes from the great Sir Isaac Newton himself in his very first law, and we also call it the law of inertia.
So what this law says is pretty simple, actually. If something's at rest, it's gonna stay at rest. And if something's moving in a straight line at a constant speed, well, it's just gonna keep doing that forever. Until when? Until some external, unbalanced force comes along and acts on it. Basically, things are kind of lazy. They don't change their state all by themselves.
And this property that makes an object resist the change in its state, it fights against that change. That is what we call inertia. In simple words, it's an object's stubbornness. It's ziddi. You know that feeling when a bus suddenly starts moving and you get thrown backward? That's your body resisting the change. That's inertia in action.
And this is where it gets really interesting, because it shows the direct link between inertia and mass. The rule is simple. More mass, more inertia. Think about it. A small toy car. How easy is it to push or stop it? Super easy, right? Because it has less mass, so it has less inertia. But now, imagine trying to push a real car to get it started, or trying to stop it. It's incredibly hard. Why? Because it has a lot of mass, which means it has a lot of inertia, a lot of that stubbornness.
Okay, so we've got the first law down. But now, if we actually want to change an object's state, how much force do we need? To figure that out, we need to understand a brand new concept, and that is momentum.
Let's think about this question for a second. Why is it so hard to catch a cricket ball that's coming at you really fast? I mean, obviously, its speed is a big factor, but is it only about the speed? Because a tennis ball could be moving at the same speed, but it's much easier to stop, isn't it? So, what's going on there?
The answer is momentum. You see, momentum measures the quantity of motion inside a body. And here's the key. It doesn't just depend on velocity. It depends on both mass and velocity. The cricket ball has more mass, right? So even at the same speed, its momentum, its quantity of motion, is way, way higher than the tennis balls. And that's why it's harder to stop.
And you know how it is in physics. Whenever there's a new quantity, there's always a formula that comes with it. And let me tell you, this formula is super important for your exams, especially for solving the numerical problems. So you're going to want to pay very close attention to this next part. So the formula is P equals m times v. Here, P is for momentum, m stands for the object's mass, and v is its velocity. Simple as that. Its SI unit is kilogram meter per second. You'll want to remember that. Now let's see how this whole idea of momentum leads us right to Newton's second law.
All right, now that we understand momentum, we can finally answer that big question from before. How do we calculate the exact amount of force needed? And this is precisely what Newton's second law tells us.
So, here's the formal definition. It says the rate of change of momentum of a body is directly proportional to the applied force. Okay, what does that actually mean in simple language? It just means the more force you apply, the faster the object's momentum will change. So the message is clear. Force is what you need to change momentum. That's its whole purpose.
And from this very law, we derive one of the most famous equations in all of physics. I like to call it the master formula. And for a good reason. Because about 90% of the numericals in this chapter, they all get solved using this one formula.
And here it is. F equals m times a. Force equals the product of mass and acceleration. This is the mathematical form of Newton's second law. And trust me, this is the one you need to remember, always.
Now, if we have a formula for force, it must have a unit, right? The SI unit for force is the Newton, which we write with a capital N. But how much is 1 Newton really? Well, 1 Newton is the amount of force needed to give a 1 kilogram mass and acceleration of 1 meter per second squared. See how it connects right back to the formula?
Yeah, this really helps you visualize that definition. Just look at it. It comes directly from F equals m times a. The unit of force, the Newton, is equal to the unit of mass, the kilogram, multiplied by the unit of acceleration, meters per second squared. It's really that simple.
Okay, let's quickly summarize everything we've covered in this explainer. I'm going to give you the key formulas that are going to be most helpful when you're revising.
Everything you need is right here in this table. For momentum, the formula is P equals m times v, and the unit is kilogram meter per second. For force, the formula is F equals m times a, and the unit is the Newton. My suggestion, just take a screenshot of this. It'll be perfect for your notes.
So, we've covered the first and second laws. Now, I want to leave you with a question to think about. When a bullet is fired from a gun, why does a gun kick back? You know, that recoil? How does that relate to these laws of motion we just talked about? Give it some thought because the answer is hidden in Newton's next law.
अगर आपको ये एक्सप्लेनर हेल्पफुल लगा हो तो लाइक, शेयर और सब्सक्राइब करना ना भूलें और कमेंट्स में ज़रूर बताएं अगर आप किसी स्पेसिफिक टॉपिक पर अगला एक्सप्लेनर चाहते हैं। मिलते हैं अगले सेशन में। कीप लर्निंग।